Hey everyone, welcome to 2.3 product and quotient rules. Also there's power over power, and there's also higher order derivatives. We are going to look here. Today's video is going to be about just the product rule. So we're going to do that and do a couple of examples, and then we'll move on so that way you don't have to watch this for 25-30 minutes or for one video, because that's hard for me to speak without making any mistakes, as I just showed you right there. So as just a reference, down here is another form of the product rule. Kind of give you some examples. Also, I really like the bottom part right here where it says first times the second is first prime times second plus second prime times first. This is a good way of remembering it. So let's go through and let's just read the words first. The derivative of the product of two differentiable functions f and g is also differentiable. Moreover, the derivative of f times g is the first function times the derivative of the second plus the second function times the derivative of the first. If you don't get all those words, don't worry about it. We have a nice little formula right down here. So it says the derivative of the product of two functions, f and g. Notice how they are both differentiable. That's part of the definition for this whole thing. Is that we have f of x times g prime of x plus g of x times f prime of x. So it's just take the differentiable, hold on, let me get the right word here. I'm annoyed with this part. I'm looking for the word derivative, guys. Derivative. Why can't I get that in my brain? Differential equation is not the correct term. It's derivative. So, I'm sorry I keep saying that. I'm looking for the derivative of the second times the first plus the second times the derivative of the first. Okay, so now let's do this example. Okay. So we have find the derivative of h of x. So what I'm going to do is I'm just going to go and try and write this as best I can. So we can say h prime of x. I probably shouldn't have used green. I'm trying to use some colors to help you see this. Is going to equal the first function. Don't do anything to it. So it's going to be 3x minus 2x squared. Okay, and then I'm going to multiply that by the derivative of the second function. So the derivative of the second function is just going to be 4. Derivative of 5 cancels out, so it's just going to be 4. That's it. Okay, and then we're going to add the second function first, which is going to be the whole thing, 5 plus 4x. And then I have to multiply that by the derivative of the first function. Derivative of the first function is going to be 3, and then it's going to be minus, and then that 2 goes in front, and this 2 comes down, so it's going to be negative 2 times 2 is going to be negative 4x to the first. So we can say minus 4x to the first. We don't really need to write. Okay, so now what we're going to do is we're going to combine everything that we can. So we're going to combine this stuff, and we're going to combine this stuff. The first one's not going to be too bad. We can just say h prime of x is going to equal 12 minus 8x squared, right? Distribute that 4. Plus 5 times 3 is going to be 15, plus 5 times negative 4 is going to be negative 20x, plus 4 times 3 is going to be 12x, plus positive 4 times negative 4 is going to be negative 16x squared. Okay, so now what we're going to do is we're going to see if we can combine everything. I've got a 12, a 15, and that's it. They are both positive, so 12 plus 15 is going to be 27. Okay, and then let's do the constants next. Negative 20 and 12 is going to be negative 8x. And then finally, let's do the x squared terms. Negative 8 and negative 16 is negative 24x squared. So now we're going to rewrite this whole thing all nice and neat, all at one time. And we are going to get this thing right here. H prime of x is going to equal negative 24x squared minus 8x plus 27. Alright, and there is your solution. Okay, and that is it for the product function, the product rule, I should say. Product rule. Words are good and important, and I need to use them correctly. So continuing on with the product rule, we're going to do this next one. Use the product rule. We're going to say d over dx, or find the derivative of x sine x. So now what we're going to do is we're going to do the same thing. I'm going to underline them again. X is my first function, sine x is my second function. So I'm going to try and rewrite this out as best I can. Okay, so remember, if you don't remember what the formula is, look down here. It's going to be the derivative of the first times just the second. So we're going to find the derivative of x. What's the derivative of x? It's going to be just 1, and then it's going to be multiplied by sine x. Alright, and then I'm just going to do plus, and now we're going to have the first one, no derivative, which is going to be just x, and that's going to be times the derivative of the second one. So what's the derivative of sine x? Hopefully you remember that it's cosine, but is it positive or negative? If you are not sure, you can always go back to section 2.2 and look it up. It's there. It's on page 107. Derivative of sine x is cosine x. Also, if you are not sure, what you can do is you can go through this front cover page, right? So you see, hey, there's my book. You can say, there's a front page and says all those basic differentiation rules. So they are all right here. So you can say, what's sine? Oh, it's cosine. Okay, very good. If you don't remember some of these other ones, u plus v, or that's the sum and difference rules. Or you say, well, what is all these other ones? So you can look them up. This is here for you to use and look up and keep handy. All right, so the derivative of sine is cosine. So we can say x cosine x. All right, so then that means dx, the derivative of x sine x, is really just going to equal, so let's just do it and make it look real nice. Dx of x sine x is going to equal sine x plus x cosine x. And that will be the solution. Okay? So, now what we're going to do is let's do this next one. Find the derivative of y equals 2x cosine x minus 2 sine x. Okay, there's a lot of stuff going on right here. So what we're going to try and do is we're going to break it up. Okay, let's just say this whole thing we're going to do first, and then we're going to do this other one second. Okay, if you notice, I've got two things going on. What I'm going to do is I'm going to put that 2x as my f function, and cosine x is going to be my g function first. All right, so we can say y prime. We're going to take that first number, and we're going to take the derivative of 2x, which is going to be just 2, and then we've got cosine x plus, then we've got the 2x times, and then what's the derivative of cosine x? If you're not sure, look at that front cover, negative sine x. Okay, there's the first one. Got it? And remember, we're also using the difference rule. I'm finding the derivative of this first part. Now we're going to find the derivative of this second part. And actually the second part, do I even really need to do too much with? It's 2 sine x, which means I can use that, multiple rule, where we have just the 2 goes in front. So we're going to have this minus, the 2 is going to be in front, and what's the derivative of sine? It is cosine x. Okay, so really, this one wasn't too bad. That was the kind of multiple rule. This one was the product rule, and this was the difference rule. So we used 3 different rules right in here. Now, we can clean this up a little bit, and we can say y prime is going to equal 2 cosine x minus 2 cosine x plus 2x negative sine x. All right, obviously these cancel out. This negative should go out in front, and we can say y prime is going to equal negative 2x sine x. And there is our solution using lots of different rules. There you go. Good luck.